Hi everyone. In this Lab 4 video, I want to talk through a few concepts that are going to be useful and important. In this lab, we're going to talk about multivariate analysis, basically using multiple variables in our regressions. But this lab is also important because we're going to talk a little bit about loops, and that will be a little bit more complicated. And we'll also talk about ways to create a whole bunch of different control variables within our regressions. So to get started, looking at our lab here, what I'm doing is I don't need to download the data again. I already have it here in my lab folder because we used it in lab 2. And I have a template. So what I'm going to do is actually, rather than just opening it, I'm going to copy and paste it, just duplicate it. And then I'm going to just call it lab 4 because that makes it easy. And then I'm going to open it up. And now I have my template, which has documentation and some good reminders about everything I need to set up. So this template already has the ACS set up to use, and it's going to look in my working directory. It's going to point to the working directory, which I set up over here. So if anything has changed, you're going to want to make sure that these things are aligned. And it's a good idea to keep a log file. I'm going to call this the lab 4 log file, so that way I don't overwrite my work from before and everything's labeled nicely. And this should be a good structure. So I can hit, if I'm using a Mac, Shift Command D to run the whole do file. I can run Control D if I'm using a PC, or I can click this little button here. Now you can see things have gone badly. I can't actually change this directory. This doesn't work. So what I need to do is go back to the working directory I'm in, and I need to just double check what's happening. So there's a few things. One, I can look and see, oh, it's actually called lab with a capital L. But if I'm not sure, I can also, if I'm using a Mac, I can right click to show the alternative menu, and I can hold down the command button, which gives me more options, or it should. Oh, it's not the command button, it's the option button. And then I can copy as path name, and then I can paste that over here just so I can take a look at what I'm missing. So let's just paste it. And you can see, oh, here's the issue. It's called lab, not labs. So that's another way you can work with things. You can also do the same thing with the PC, but I don't remember the shortcut offhand. So I just click this button, it runs, it opens, it closes, it runs without any errors. End of do file is reached, so my template is ready to go, and in my variable window I have all of my variables. It's always good to familiarize yourself so you can describe the data and you can get a sense of the information that's available. You might prefer to browse it. Remember to watch out for these blue labeled variables because they are labels and they hide a number underneath. And we also can do codebook, which is a nice feature that gives us perhaps more information than we want. Maybe you only want to do this for 1 or 2 variables at a time, like that. But it helps us understand what the data is, what the range is, etc. So once we have this, we're ready to get going and start working on the lab itself. So what we're going to be doing is creating some binary variables, working with some loops, and also working a lot with binary independent variables in particular. So in terms of what we need to do, the other thing to get familiar with is just our loop. So you can download this file. It'll save to your downloads folder. My downloads folder is over here, so you can see me just drag it over there. And I'm just going to get rid of this extra parentheses because it's ugly and I don't like it. There we go. And so if I open this up, this is the loop file that we're going to work with. The reason I'm showing you this is not that it's 100% mandatory. It's just a way of building our intuition about more complicated things we can do with coding that will make our lives simpler in general. So this you can actually run no matter where you are because it doesn't use any data, but the structure is important. So essentially what this tells me is we're going to clear, we're going to set a random seed. This is useful if we ever need to generate a random number. It means that it becomes replicable. Essentially, if I am generating a random number and I don't set the seed, every time I run it, I will get a different set of numbers. But if I set the seed, basically what it means is that it will start from sort of the same part of a very long set of potentially random numbers, and it will generate it that way. And that makes things replicable. So I'm just going to run this line by line so you can kind of see things here in the command window. But we clear. So that just erases my variables from my variable window. I'm going to set my seed and set my observations. I'm going to switch to keyboard shortcuts just to go a bit faster. And you can see the number of observations is now 10,000, but I have no variables. So here's my first loop. What this says is it says for values I equals 1 parentheses 1 to 100, generate X, and then it's got this funky little I, and then it says R uniform. So walking this step by step, what the inside, when we have a loop, it starts with this open curly bracket and it ends with this closed curly bracket. And the stuff inside is the kind of the meat. So everything within those parentheses can be one command, can be a series of commands. They cannot be on the same line as this. They have to be in between, and you can use more spacing if you like to make it easier to work with. So what this does is it says we're going to have a local variable, a temporary variable. We're going to call it I. And first it's going to be 1, and we're going to run the loop. And then we're going to go up by 1 and run the loop, and then by 1 and run the loop over and over and over again, up until I becomes 100. So basically we're going to run this loop 100 times. Inside the loop, it's going to refer to our little local I that we generated. And the way we call it is with this backslash button here, which is the key that is below your escape. It's not an apostrophe, it's a little dashy body. I don't know what to call it. I call it a backslash, but that's not right. It's the quotation out of the tilde. And then this is our straight up and down apostrophe. So there's different ones here. So it's this one, this one, this one, and that calls this value here. So if this value is 1, this will become a 1. When this value is 2, this will become a 2. And so what this will do is it will generate x1 is a random number, x2 is a random number, x3 is a random number, and it will do this 100 times. To run a loop, you need to select the whole loop. If I run this line of code, it won't know what this local is, what this little I is that turns a teal. So we need to run the whole thing together. I'm going to press do, and you can see that I generated, every time I ran the loop, I generated a new x, and it plugged in this value of I for this backward slash I vertical apostrophe. And if I browse, you can see that there's a set of random numbers for all 10,000 observations generated 100 times. The other thing, this is a command in and of itself. It means generate a variable from a random, it's the R, uniform distribution between 0 and 1. That's exactly what it will do. There are other types of commands like this. It doesn't have any arguments because it's just a standard normal. Now we have a new one. So here we have another loop. And I've typed for val, but that's just short for 4 values. These two are equivalent. And it says that we're going to have a new local variable called num. You can have any name. You can call it Charlie if you want. It starts at 10, it goes up to 20, and it goes up by increments of 2. And what this will do is it will say count all my observations if x, and then plug in that number, is greater than 0.9. So I'm going to run this, and it will help you see better. So what it does is it starts with x10. It counts for x10 how many of these x10s are greater than 0.9. It's the same as count if x10 is greater than 0.9, and I get 998, which is the same here. Then on the next loop, it will it'll increment by 2. So it's incremented by 2, and I get 988, and that's what I got here. So basically, it's looping from 10, then 12, then 14, then 16, then 18, then 20, and just displaying this information, which is what this is. So I can loop by 1, I can loop by 2s, and I can have commands, and I call these little numbers. Now, I might also want to do this with strings. This could be very useful if I want to do the same thing over and over again. So I have a new loop here. For each name in Annette Fett, Ashley Poole, Marsha Martinez, I'm going to display the length of that string, and then I'm going to write characters long, and then I'm going to put the name in. So this is a little bit hard to read. Let me run it and it'll be clearer. So what happens is I have for each name, notice this is different than for values. So there are for values commands and for each commands. For values can only do numbers. For each can do all sorts of things. And name is just a variable I made up. I could have called it Charlie. And then here is the list. There's one, this is a string, this is a string, this is a string. And so at first, name will be equal to this string. And then name will be equal to this string. And then name will be equal to this string. And then it will stop. Display is just a command that just displays whatever I want, right? So I can write display 2 + 2, display hello, but you have to put any sort of strings in quotation marks. So we have display. This is a string function. It says, tell me the length of whatever is in these quotation marks, and it will be this. So it's going to be the length of this string. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's going to count the space. Then this is going to have, it's also going to display this string, which is just literally words that I've typed, characters long, and then it's going to put the name right in there. So it's going to put that in. And that's exactly what happened up here. The last example is that I can also use for each to make up something. Again, I called this var, but again, I could call this banana. That's also fine. And in this case, you'll see it's of var list. What this means is I'm telling it, it's not just this random list of strings, it is a list of variables. And when I do that, I can do things like this, like all the variables that start with X and then that start with X. So this is very handy. I can't do this because then it will literally look for X and then an asterisk. But here it's saying, find me all the variables that start with X. For each one, summarize them, and then summarize them if the variable is greater than the mean plus the standard deviation. So basically, if the value is more than one standard deviation above the mean. And we'll see what that looks like too. And so let's just start with example 100. So we summed all of them. This generates some background statistics we can use later. And then if the observation is greater than one standard deviation above the mean, if it is above 0.5 plus 0.289, then summarize it. And so you can see here from the mean, the minimum, that indeed, these are all variables that go from there all the way up to the max. Where this is coming from, this is just kind of a cool thing you can do. So if I summarize X100, I get these statistics listed for me. But if I type return list or ret list, you'll see I get these scalars. And basically what these are temporary variables that hold the values from up here. So for example, our n is 10,000 because that's the number of observations. Our mean is this one, which is this one. Our standard deviation, min and max. If we want more of them, we can do detail. And now we have lots of them. And now we have lots of different scalars we can use. This is handy because then I don't have to hard code this by entering the exact mean. I can just say, summarize it if it's greater than its mean and standard deviation. But I have to run the summarize first. If I just try to do this without having this command first, it won't work because there won't be anything saved. See? The mean is essentially 0 and standard deviation is 0. There's just nothing here because this isn't declared. So we have to have this here, and then we have these variables, and it will work for us. So there are lots of applications for these. We're going to use a few in the lab, but I wanted to highlight how to work through those. Now, in terms of the lab itself, we need to restrict our samples, we need to generate a birth year, and then write a loop to generate a dummy variable. So let's just talk through this a little bit. So we need to keep if the individuals are aged 25 to 35. So I'm just going to paste this in here as like a little example to myself. just a little note so that way I remember what I'm doing. So I need to find age. Now I've lost everything here, so I'm just going to rerun this command, this whole code. And if I'm lucky, I see age. If I can't find age, I can look for age. And I'll see, oh, age right there. And then I'm going to tab it just to make sure I understand it. And you can see it looks a little bit weirder than I might have expected because of this. Just the top coding of the age being 90, but that's not really relevant for us. And I can also describe it and make sure, okay, it's a number. So we're probably good to go here. And so what I'm going to do is I'm going to keep if age is greater than or equal to 25 and age is less than or equal to 54. Now, if I'm not sure if this is going to work, maybe before I do keep, I might copy this and I might tab it instead. So tab the ages. I have to tell it what to tab, but I could tab age just to make sure that this actually gets me the numbers I want. I'm like, yep, everyone's 25 to 54. So now I'm going to run this. And that gets rid of a lot of observations. And you can see that I still have 30,000 people to work with, but I have fewer. Now I'm going to want to then create a birth year variable. And your birth year is, in this case, going to be 2024 minus your age because our survey is in 2024. If you're not sure what survey your year is, or you have a lot of years, you can tab year and you can see it's 2024. A more robust way to do this would actually be to just use birth rate is year minus age. So we do that, and then we can tab our birth years. And again, it's good to double check this to be like, okay, if somebody is 25, then they could be born in 1999 and up to 1970. And that should be pretty reasonable, but it's a good idea to check it. And also just to make sure there's no missing values, which we don't have here. So that's pretty lucky for us. Now, the next thing we might have to think about is generating a dummy variable for each possible value of birth year. So essentially, just so you know, the shortest way, the kind of most basic way, but tedious way to do this would be like generate birth year 1970. Oops. And then we could just do this again, right? This will work, but this will take forever, and you didn't use a loop. So this is horrible. Do not do this. I'm going to comment this out. So we're not going to do that. What we can instead do is think about the pattern in the variable that we want and the variable we're working with, right? You can see that we basically need a dummy variable creation command that creates a variable equal to 0 if the statement is true and 1 if it's false. And then it needs to repeat. You can also see that the structure is exactly the same. So what I'm going to do is I'm just need numbers, so I can use 4 values. And I like I, just it's easy. And basically what I want to do is I want to start with 1970, and I can do it like this. And I want to go all the way up to 1999. Another way you can write this if you want is you can do it like this. That just automatically increments it. When you type the open brace, it'll make another one, a close brace, just to make sure you've opened and closed everything so nothing's left hanging. And you just want to type in here. So now I want this command, but I need to get rid of all the numbers. So I want to generate birth year. Now to call my I can't just write I because it'll just think that's the letter. So I have to use this special backwards apostrophe that's on the tilde button below the escape key, and Stata will automatically close it for you. And I just put an I, and then that's equal to 1 if this is equal to I. So this does the same thing as this, it just does it over and over again. So we can run this to make sure it works. And if I scroll down, I should be able to see all of my birth years, and I can also just check. That's pretty good. Make sure there's nothing missing, and I can check 0, and 95 is missing. So things are looking pretty good here. This is the idea with our loops here. I'm going to leave you to think about the variables and the data you want to look at and what these mean. But I did want to note here, when we're thinking about our income and wage, it's coded as a really big number. And you can see this if we tab Inc. Wage. Oh, actually, they're all gone now. They were there before. In this case, we don't have an issue. But we could check and make sure that there aren't any values here. And so what we might do is make sure that there are any sort of NA values that we might see, and we might need to replace them. In this case, it looks like we don't have any over here. And yeah, we don't have any anymore. I think the people for whom it was invalid got dropped with our age restrictions. So we're actually good to go there. The other things I think should be relatively straightforward. But the last thing I wanted to show is just this idea of a birth year fixed effect. So as an example, let's pretend I wanted to look at the relationship between birth year and wages. We're always going to use robust, right? And so check our spelling. When we do this, we get a regression like this that shows that your income and wages go down as your birth year goes later, most likely because of age. And these two things are collinear, right? So if we tried to do this, age drops out because it's literally a linear function of 2024 minus age. But that's fine. So we have that here. But if we want to kind of capture the fact that we don't necessarily expect it to be a line, we might want to include all these different variables. So one way we can do this is we can literally type and we can just keep typing it, right? And it works. It gets the job done. Except you have to keep doing it, and you also have to make sure that you've spelled things correctly. And so the propensity for typos gets kind of more and more annoying. What you can also do is you can use an asterisk to indicate anything that starts with birth year. Now you want to make sure if you do this, you don't have anything that you're not expecting. And you'll see here that we had birth year and then we had all these dummies. And you'll notice actually that 2 of them drop out. Now when I see 2 drop out, that kind of raises some concerns because I should have only expected 1. But that's because I left birth year in here as well. So we need to get rid of that. So this is what I mean by there being an issue with just putting birth year in. So I could do this so that way I only get the ones that have a 1 in there. And now you can see that this is the wage differential with respect to people born in 1999 who are omitted. So people born in 1998 earn a little bit more, then these folks earn a little bit more, these folks earn a lot more. This is probably around the time people have kind of completed college, or they've entered the labor market more, and then you can see the wages go up as they get older, and then kind of start to fall a little bit among the oldest folks in the sample. We haven't controlled for anything else, so there could be all sorts of things happening. So this works. What's nice about this is you actually, in this approach, you can control who you want to be omitted. So you could do 1971, 1972, all the way to 1999, and that would work. But if you don't want to generate all those variables, you just want to use them one-off, then essentially what you can do is you can also use this sort of work. I'm just showing you because we're going to come back to it later, which is you can do I.birth year, and then robust, because we're always estimating heteroscedasticity robust. And so here, we're doing the same thing, and we basically have a series of binary indicators relative to birth year for all of these variables. Now notice these numbers are very different than these numbers, and that shouldn't be surprising. It's because now these are relative to 1970, whereas the others were relative to 1999. So if you do this, you also have to be careful, but notice it doesn't show you what's dropped. It basically automatically included them, just the ones you needed, and didn't include the other one that would be perfectly predicted by the remainder of them. And so you just want to be really careful about who your reference group is. So in short, this is a really quick way to do things. This way gives you maximum control. And this way, using, say, an asterisk here, but making sure that it's perfectly identifiable, that will also work. So those were things I wanted to stop at. I think everything else we've got the status skills for. So happy coding.